Hello class. Today we're going to be doing a video on section 5.2. I'll be assigning 5.2 today, April 14. It'll be due on April 21. The previous lesson we looked at simple interest. It was one of the most basic ways of calculating interest that we can do. One of the more common methods, though, the one that you're going to see it quite a bit in your lifetime, is referred to as compound interest. It is interest that's periodically paid on an existing balance, which includes the original principal and any previous interest. This part right here is why it's oftentimes referred to as interest on your interest. What do I mean by that? Well, we get interest on our original principal, but if we're going to get interest on the principal and previous interest, that means I'm getting interest on this previous interest. Hence, we say interest on your interest. One of the terms that we'll be using is referred to as compounding period, which refers to the frequency in which your interest is computed or deposited. For example, if it's compounded semi-annually, that would be twice a year. If it's compounded quarterly, it would be 4 times a year. Compounded monthly would be 12 times a year. Compounded daily would be 365 times a year. Our next problem is we're going to take an example where we're going to keep the numbers pretty much the same for both examples. But one of the examples, we're going to find the simple interest calculation. The other one, we're going to go compounded. And again, we're assuming no taxes taken out. Okay? We're looking at the difference between these two methods. This first method is simple interest. It's like what you did in the last section. So I'm looking for basically finding the future value of some account. I'm depositing $100,000 for 20 years, and it's going to pay simple interest at 6%. The formula that you did in last section was this one. This is my original principal. This is my future value. R is the interest rate per year. Time is the number of years. So plugging that in, my principal was $100,000. My interest rate is 6%, and it was for 20 years. We multiplied these two and we added it to 1, which gave us 2.2. Take 2.2 times 100,000 and we would get 220,000. What that means is if I had put 100,000 in to some account for 20 years at 6% simple interest, after 20 years, it would be worth 220,000. Now we're going to take the same problem. We'll come back to that number 220,000 from this example. But now we're going to do the same problem, but we're going to be using compound interest. We're finding the same type of future value. We're putting in exactly the same amount of money, 100,000, same amount of years, 6% paid out monthly, interest compounded monthly. That means every month or 12 times a year, we will get our interest times that amount. The monthly interest, though, is not 6% every month. 6% is a yearly interest, which means every month we get another rate. Our monthly interest is what this was in a year divided by 12 months. That means we get 0.5, half of 1% every month. Okay, I want to say that again. Every month we'll earn half of 1% of interest. This monthly interest rate is called our periodic rate, and it was determined by the fact that it was monthly. So I divided the annual rate by 12 months. Had it been compounded quarterly, I would have taken 6% divided by 4. Had this been compounded daily, I would have taken 6% divided by 365. It's important when we do this division, we don't round off. Take as many decimals as you can from your calculator. Rounding off here can have a huge difference in the overall outcome. So don't round off until at the very end, you round off to the nearest cent. I'm going to say that again, don't round off until the very end, then round off to the nearest cent. So after the first month, we would have a new balance. It's because every month we get paid out our monthly interest. So after the first month, I would have a new balance. That's going to be shown on this next slide. You remember a moment ago, we found our monthly interest rate was 0.5%. That's 0.005. So then after 1 month, I would have 1 plus 0.005. That's the interest that I got in 1 month. The 1 taken times 100,000 gives me my original 100,000. But this 0.005 times 100,000 gives me my interest. So if I add these together, take it times 100,000, I get 100,500. What does that mean? It means that in that first month, I started with 100,000, and now I have 100,500. I gained $500 interest in that 1 month. So now my new balance after the first month is not the 100,000, but my new balance is this 100,000 plus interest, 100,500. That may not seem like a big deal to you, but notice this. During the second month, month 2, I don't have 100,000 getting interest. I've got this new balance from over here, put in here. That new balance is getting the same interest that 100,000 was in my first month. So after the second month, I get this interest plus what I started with. Now I have $101,002.50. Notice that I gained another basically $502.50. Last month I gained just $500. This time the difference from here to here is $502.50. So this becomes my balance now for the third month. Notice that number goes right in here. Take it times the same periodic interest. And now I have 101,507. And again, I kept the decimal going. Month 4, I would have taken this in there, taken it times the interest. That would keep on going for how long? Well, if you recall my original problem, we were doing this for 20 years. So if I did this every month for 20 years, it would be 240 times. 240 times. That would be a lot of work, calculating that. Because it's 20 years and we're doing it every month, it would be 20 times 12, 240 future values that we would get. That would give you a final future value. Notice this would be after month 239. Look at what I have in there, $329,373. Month 40, $331,000. Well, check that difference once. So before we do that, we could have done that whole process much easier. The whole process could have been done like this. We could have taken the 100,000 that we started with. Every month, we multiplied it by 1.005, 1.005. This was the first month. we took that product times this for the next month. We would take that product times the next month. We would do it 240 times. Here's how we make it much easier though. These numbers would have been the same 240 times. So I just take that to raise it to the power 240. Thankfully, we have a calculator that can do that. We just punch it into the calculator. Excuse me, 1.005, that's this number, raise it to the power 240, hit enter, and you can see I get that 3.3102 that I have right here. Don't round anything off, take it times 100,000, and that's where we get that final amount. Notice the comparison here. I got this same amount on the next sheet. As I did, remember, one of the first ones we did was the simple interest, 220,000. But now look at the difference between these. It's a huge amount. If I did simple interest for 20 years, I got 220,000. If I did compound interest for 20 years monthly, I get $331,000. That's $111,000 more. That's a huge amount. Make sure that you can do this in today's lesson. You can take this number, add it to 1 in your calculator, go exponent 240 times, hit enter to make sure you can get this 3.31020, etc. I'm going to show that here on your calculator again. I'm going to take this 0.005 plus 1, 0.005 plus 1 equals, there is that 1.005. I'm going to raise it to the power 240. That's exponent right here, exponent 240. Hit enter, and that's where I get that 3.31, etc. Then I would take that times 100,000, and that's where I get this $331,020. I would have rounded it off to 45 cents at the end. But again, make sure you can do that calculation on your calculator. Practice it many, many times and it becomes automatic for you. That shortcut that we just did is really what this future value for compound interest formula is all about. So in your notes, put down compound interest formula, copy all of this down, and then make sure you have this formula down. Each of those variables are described here. FV is the future value like it's always been. The original principal is P. I is my periodic interest rate for n periods. And here's how we get them. I is the yearly interest rate divided by the number of times it's compounded per year. N is the number of years multiplied times the number of times compounded per year. We're going to do many examples, so this will start to make more sense to you. But pause the video right now. Make sure you copy all of this down, that you have that in your notes, okay? Go ahead and pause it, and then when you're done, start it over again. Let's take a problem like this once as an example. What I'm going to do in this example is I'm going to go back to the simple interest formula, do it one time there. Actually, we just got done with that. This is this. And then we'll do it compounded quarterly, compounded monthly, compounded daily. So I'm going to do all of these once for us right now. Okay, first of all, this is from the previous lesson. If you remember that formula, it's in your notes. The future value, it was equal to the principal multiplied times 1 plus RT. So in my case, my principal is $5,000. 1 plus the interest rate, which is 0.08, times the time in years. Well, from 18 to 65, how many years elapsed there? Well, we would have taken 65, subtracted 18, and we would have gotten 47 years. So my time here is 47. You would multiply these two together first. So 0.08 times 47, enter, plus 1, enter, times 5,000, enter, and you would be done. And what you would end up with is 23,800. That's A. Now let's go to compounded quarterly. This one is new for us here today, okay? Our formula, which you got down, future value, it was equal to the principal multiplied times 1 plus I raised to the nth power. We're going to have to first calculate each of these. The I, for example, if you remember from that previous page, it was our annual rate, 8%, divided by how many times it's compounded. Well, it's compounded quarterly right here, which is 4 times a year. So I would take 8.08 divided by 4. This one happens to be a nice number to start off with. Most of them are not that kind, but that would be our I value. Our N is going to be the number of years, 47 years, times how many times it's compounded per year. Quarterly means 4 times a year, so 47 times 4 is going to be 188. You have to do these calculations first, then put them into that formula. So now let's grind through it. Once my principal was 5,000, 1 plus I, which is 0.02, raised to the power 188. Again, on my calculator, I'm going to go 0.02 plus 1, enters. That gives me 1.02. I'm going to raise it to the power 188. So here's my exponent button. Raised to the power 188 gives me that answer, which is 41.3839834. I'm going to be taking that answer times 5,000. So now I would go times 5,000, enter, and I would have my answer. It would be, in this case, 206,919.917, which we would round off to 92 cents. Look at the difference here. This was the future value with simple interest. This is the future value compounded quarterly. Huge difference there. If it's compounded monthly, I would take my same formula. It again is the future value equal to my principal times 1 plus I raised to the nth power. My I is not going to be quite as nice this time. I'll put it down here. It's the yearly rate, 0.08. Last time we divided by 4 because it was quarterly. This time we're compounding it monthly, so I divide that by 12. That answer, 0.08 divided by 12, turns out to be 0.006 repeating. And I would keep as many of those on my calculator as I can. So I have to put in my 5,000 here, excuse me. And I put in as many of these as my calculator will hold. I have a few more on mine, you might have more or less, but now I need to get my N right there as well. That N is the number of years, remember that was 47 years right up here, times, last time I took 47 times 4 because it was compounded quarterly. This time it's compounded monthly, so I'm going to take it times 12. I don't know why I put 42 there. It's supposed to be 47. Well, 12 times 47 gives me 564. That's my exponent. Okay, so now we're going to go to our calculator. I'm going to have this right here. What I basically did is I took 0.08 divided by 12, and you can see on my calculator there's a lot of 6's there. I'm going to add 1 to it, so I'm going to go plus 1, enter, because that does it. Now it's 1 point all those 6's. I'm going to raise that to the power 564, so I'm going to take it exponent 564, enter. That gives me that number 42 something. 42.41584914. And I'm going to take that answer times 5,000. Enter. And I get my answer here. Turns out to be 212,079. I'm going to round it off to the nearest cent, 0.25. Notice again, simple interest, 23,800. Compounded monthly, 206. Huge jump right there. This jump compounded, this was compounded quarterly. This one's compounded monthly. Not a big jump, about 6,000. Finally, if we were to do it daily, I would have my future value. It would be the principal, 1 plus I raised to the nth. My I is going to be the annual rate divided by 365. Because it's daily, compounded daily, divided by 365. Going to be a nasty decimal. Then I could also get my N. You remember it was 47 years times 365 because it's compounded daily. I'm going to put that in there once. 47 times 365 is 17,155. That number I wanted in there right away. I'm going to try and show you maybe the simplest method to do this all at once, okay? So let's put it in here once. My principal is 5,000. My I was 0.08. divided by 365. The N I already calculated right here to be 17,155. If I were to do this problem all at one shot, this is not the only method, I get that, because some of you prefer to use parentheses and brackets, but a lot of people would prefer to do this. We'll start from the inside. We're going to go 0.08 divided by 365. Enter. That does the division, gives you a nasty decimal. It's what this would have been. What am I going to do with that decimal? I'm going to add it to 1. So I'm going to go plus 1, enter. That's put all of that in brackets into one number. It's actually this number on your screen. Then I'm going to raise that to the power. So I'm going to go exponent. 17,155, enter. That gives you this whole number right here. It actually turned out to be about 42.93073,496. What am I going to do with that number? Take it times 5,000. Enter, and I get my answer, 214,653, rounding it off, 67 cents. Okay? Replay that you can do that on your calculator multiple times to get this answer, okay? This particular problem is to help you understand why people get kind of excited when interest rates go up or down. Sometimes some people are excited when they go up, other people are discouraged when they go up. Sometimes people are excited when they go down, other people are discouraged when they go down. This problem is designed to help you understand the difference. We just did the 1 and 2. So I'm going to just copy in those answers once. We did the simple interest. And in 47 years, we got 23,800. That was from the previous couple of problems. We also did this one, compounded monthly. Notice I'm going to go monthly, monthly, monthly for all of these. The only thing I'm going to be changing is the interest rates. We did this one, and it turned out, if you remember, to be $212,079.25. Let's now take a look at number 3 and 4 and then compare those values. The formula, it's compound interest, so it's principal times 1 plus RN. I'm going to put those numbers in just directly here this time, 5,000. In this case, I think that was supposed to be an I. I wrote down the wrong. That is going to be our 12% compounded monthly, which would be 12. And it would be monthly for 47 years. 47 times 12 gives us 564. Then watch my calculator procedure to do it all at one shot. Okay, I'm going to go 0.12 divided by 12, enter. Add it to 1 plus 1, enter. Raise it to this power, 564, enter. Take it times 5,000. And I end up getting this answer, 1,368,437.03. 1,368,437.03. The only thing that changed from number 2 to number 3 was the interest rate. Look at the outcome though. It is about 6 times more. That is why if I'm investing money, I love the higher interest rate because I'm going to get a future value much greater. But if I'm borrowing money, those higher interest rates means I'm going to be paying this extra amount. It's going to cost me. Likewise, if you go to 4%, watch again the difference. Principal times 1 plus I raised to the nth. The principal is still the 5,000. The I is this time it's 4%. Compounded monthly means divided by 12. 47 years times 12 months, same as it was last time, 564. I'm ready to go to my calculator. So I start from the inside out, 0.04, divided by 12, enter, plus 1, enter, raise it to the power 564, enter, times 5,000, and I get that answer this time to be 32,665.24. Compare that to 1,368,000. The only thing that changed here, this one again was, make sure I copied that down correctly, 32,665.24. Look at the difference between these. Interest rates, especially over a long period of time, 47 years, interest rates have a significant difference from one value to the other. It is why when interest rates are down like they are right now, investing doesn't pay back as much, but it's great for the borrowers. Back in the late 70s and in the 80s, interest rates were oftentimes between 10 and 15. People that were investing got huge payouts. People that were borrowing had to pay huge amounts. Right now, we're more in this setting right here. That can change in a matter of a couple of years' time. You likely will see some of all of these sometime during your life. In the 60s, this was common. In the 70s, this was common. 80s, this was common. It can change a lot. But notice again the difference. That slide is trying to indicate the difference between interest rates. Now, I'm going to do a similar type of comparison, but this time we're going to do everything the same interest rate, compounded monthly, but I'm going to go for 10 years, 20 years, 30 years, 50 years, etc. We want to find the difference in the balance every time. So let's start off here with number 1. First of all, my formula, future value, principal, 1 plus I raised to the nth power. This one, my principal is again 5,000. My I is going to be the interest rate divided by how many times it's compounded. Compounded monthly means divided by 12. So 0.08 divided by 12. The N is the number of years times how many times it's compounded per year. Compounded monthly is 12. 12 times 10 years, 10 times 12, 120. I'm ready to go to my calculator. 0.08 divided by 12, enter, plus 1, enter, raise it to the power 120, enter, take it times 5,000, enter, and I get my answer which turned out to be 11,098 and 20 cents. It's because we only had it in there for 10 years, not that long. Compare that to number 2. Future value would be principal, 1 plus I to the nth power. That would be 5,000. 1 plus the same 0.08. Divided monthly means divided by 12. But this time, it's for 20 years. So it's 20 times 12, or 240. Again, I won't be showing this too many more times, but one more time here. 0.08 divided by 12, enter, plus 1, enter, raised to the power 240, enter, times 5,000, enter. And this time I got 24,634 and 1 cent. Going to number 3, same formula. Principal, 1 plus I to the nth. Principal is 5,000. 1 plus 0.08 divided by 12. But this time, n is 30 years times 12, or 360. If you grind that through, what you end up getting is 54,678 and 65 cents. Rather than showing these in the formula, I'm just going to give you the amounts here. This would be 121,366.93. 50 years would be 269,390, and I think it's 92 cents. Okay, take a look once. 11,000, 24,000, 54, 121,000, 269,000. That's going from 10 to 20 to 30 to 40 to 50 years. Now, I want you to also catch this once next. The difference between the 10 to 20 years, I took 24,000 minus 11,000. I'm not going to do it exactly, but it's approximately $13,000 difference. The difference from 24,000 to 54,000 is approximately 30,000 difference. The difference there from 54 to 121 is approximately 66,000. The difference here is approximately 148,000. Okay? Do you see that every 10 years it gained 13,000, here it gained 30, here it gained 66,000, here it gained 148,000. There's a very, very important principle for you guys to understand financially. Sometimes people will say, when should you start saving or investing for retirement? And a lot of times the answer given in humor is, you should have started saving yesterday. Well, that's kind of a jest answer. But the point is, they're trying to help you understand that you don't get these kinds of gains at the end unless you invest early. For example, take a look at this now. Here's a chart, graph, if you will. And I would like you to think of this as 10 years, 20 years, 30 years, 40 years, and 50 years. We have some amount that we started with, 5,000, right at the beginning. After 10 years, it was up to, up to 11,000. That would be about here. My graph did that. After 20 years, it was about at 24,000. After 30 years, it was about at 57,000. I apologize, 54,000. At 40 years, it's at 121,000, way up here. And this one would have gone right off the chart. This is referred to as an exponential growth, okay? Notice you don't get a lot of growth in the first 10 years. We said about, I forget what it was, would have been here, from 5,000 to 11 would have been 6,000. Then we gained 13,000. That was this difference. This gain was about 30,000. The next gain was about 66,000. Okay, well, my point for this is to get these big jumps, which, by the way, you're not doing anything. Your money is just working for you. You're not putting in 40 or 60 or 80 hours a week. This money is earning its interest all by itself. Listen carefully now. You can't get these gains, the big ones, until after the 30, 40 years. Which means if you start to invest when you're 50 to retire, you're only going to get that kind of gain. If you start to invest when you're 40, you get both of these. If you start to invest when you're 30, you get those. If you start to invest when you're 20, you get those. The big gains come after a long period of time. That's why they say, when should you start to invest? Yesterday, because they want you to get these big gains, all right? That was the difference between this 10, 20, 30, 40, and 50, okay? The next concept is where we're simply using the formula and working it backwards. It's not a real difficult one. It just involves a few algebra skills. It says find the present value. That would be like the original principal. So in my formula, the present value is referring to that P. They're going to give you everything else except the P, and you got to figure out what that is. Okay? Notice they tell you the future value, FV, is 100,000. We have to find the present value. That's the original principal, present amount that we started with. My I is, in this case, it's 10%. We don't divide by 12 now because it's compounded semi-annually. It's not compounded monthly. If this were monthly, I would divide by 12. Semi-annually means twice a year, divide by 2. And my number of years, previously we took that times 12 when it was compounded monthly. But if it's compounded semi-annually, that's 2. 2 times 25 would be 50. There's my substitutions. Well, what I got to do is I've got to get all of this into one number. Same old calculator exercise. 0.10 or 1 divided by 2, enter. Plus 1, enter. Raised to the power 50, enter. Notice that's your number in there, 11. 0.46739979. I need to divide 100,000 by that number now. So you'd go back to your calculator, divide that back in. A shortcut, I have this long number on my screen. I can punch this x to the -1 right here. That will reciprocate that. That'll take that long decimal, put it as a reciprocal, take it times 100,000, times now there. And you get that original principal to be, in this case, 8,720.37. If you're comfortable with that, that is a shortcut. If not, just clear your screen, punch in 100,000 divided by that long decimal. You should be able to get this amount. Let's make sure we understand what this number means in context of this problem. Sometimes, and maybe some of you in this class have this, you have grandparents that are pretty well off. Sometimes grandparents would want to put 100,000 or want you to have 100,000 by the time you reach age 25. So when you were born, they had to decide, if I can lock in an interest rate, sometimes you can for 25 years on bonds. If you can lock in an interest rate at 10%, they would say, how much would I have to put away now when you were born so that when you reached age 25, there would be 100,000 in there for you? Well, you would have to put in, your grandparents would have had to put in $8,720.37, lock in the 10% for semi-annual, and at the end of 25 years, it would have been worth 100,000. That's your present value. 8,720 is what they would have to put in presently so that it would have a future value of $100,000. I don't think I need to do this too much more, but maybe I should here. Let's do one of these. Let's do this third one right here. Again, I want a present value. It's not super hard. Future value equals my principal present value, 1 plus I to the nth. The future value happens to, again, be 100,000. In your exercises, they might give you any old amount. I don't know the present value. My I is the interest rate, 6%. Semi-annual compounding is twice a year, so 6% divided by 2. Twice a year for 45 years, 2 times 45 would be 90. I need to get that amount. So again, 0.06 divided by 2, enter, plus 1, enter, raised to the power of 90, enter. That gives me that number, which happened to be 14.300467111. You can either clear your calculator, take 100,000 divided by that, or take this number, reciprocate it, times 100,000. It's a little shorter. You don't have to punch in all the numbers as often. And sometimes when you punch in numbers, you get them easily messed up. $6,992.78. That is what I would have to put in presently, so that in 45 years at 6% interest only, it would be worth 100,000. Okay. Our last concept. This is maybe the more difficult one of today. Okay. Need a couple of definitions here first. I'll get another paper here. This is our last concept, but it's kind of tricky. Annual yield. You may see that if you walk into a bank and they'll talk about their CDs, cash on delivery. and they'll talk about an annual yield. What exactly do they mean by that? Well, an annual yield of a compound interest deposit is the equivalent simple interest that has the same future value as the compound rate would have had in 1 year. We've been working with compound rates. Last class period, we worked with simple. Well, a simple interest rate that is equal to the compound, same as the compound, is known as the annual yield. Annual yield equals the compound yield after 1 year. Okay, 1 year being a key here. Don't lose sight of that. The nominal rate, just like it was earlier today, is the annual, the yearly yield. It's different than annual yield. Nominal rate and annual yield are not the same, okay? Remember 1 year. Remember 1 year. Here's why I'm saying that. Here's our example. Find the annual yield of 20,000 deposited at 15% compounded monthly for 20 years. Here's what we're looking at. This formula was our simple interest rate, our simple interest formula for a future value. This is the one we've been working at today, future value of compound interest. Remember I said for 1 year. So this 20 is immaterial to us. We're looking at this for 1 year. Okay? Because these are all going to be equal, I can cancel off, and I'm looking at these two right here. Principal times 1 plus I to the nth has to be equal to principal times 1 plus r to the t. Well, it's an equation here, which means I could divide both sides by the principal. And what I would get would be 1 plus I to the nth, 1 plus RT. This formula is our formula to find the annual yield. When my time is 1 year, remember I said remember 1 year? Then my annual yield is going to be that R. Pause it, copy all of this down, rewind it, try to listen to that again, okay? I'm going to take this formula and rewrite it here for this problem. So pause it, copy it down, and then listen to it again. I know I have extra numbers like 20,000 in there, but we could have just divided both sides by 20,000 and that would have been gone. We would have had this left, these two parentheses. Excuse me. Because it was 1 year and it's compounded monthly, 1 year compounded monthly is 12 times 1. That's where that red 12 came from. 20 had nothing to do with that. In our simple interest formula, T stood for the number of years. Because annual yield is always referring to 1 year, I have a 1 there, not a 20. Can't emphasize enough, that is going to be based on 1 year. If it had been compounded quarterly, it would have been 4 times 1 year, it would have been a red 4. This would have still been 1. If it had been compounded daily, 365 for 1 year, this red number would have been 365. This would have still been 1. This will always be 1 here for this annual yield problem. So putting that in, I have 1 plus 0.15 divided by 12 raised to the 12th power. When I do that, this just gives me 1 plus R. Remember, R is my annual yield here. So I end up getting these two numbers, this one on my calculator. I subtract 1 from both sides. Right here, I subtracted 1 from both sides, giving me just that decimal now, which I write as a percentage. This was just the R. What does this 16.08% really mean? It means this. If I had taken this 20,000 and put it at simple interest, I would have had to put it at 16.08% interest to give me the same amount as what 15% interest compounded monthly. I'm going to try to say that in a different way. 15% compounded monthly is the same as 16.08% compounded yearly. What I have compounded yearly is my annual rate. Okay? Finishing up here. Let's take this problem right here. This one gives me 8% daily. This one gives me 8.2% monthly. I want to find out which one gives me the better annual yield. Okay, so to that end, let's go with this one once. First one, remember it was the following: 1 plus I to the nth year was equal to 1 plus RT. This is going to be 1. My I is going to be 8% daily. That's 0.08 divided by 365. Remember we said 1 year, so I ignore the 10 and I'm looking at annual yield. 1 year compounded daily. How many days are there in 1 year? 365. This will be 1 plus R. I'm looking for that annual yield for 1 year. That's going to give me just 1 plus R there. I need to get this amount. I'm going to go to my calculator. 0.08 divided by 365, enter. Add 1 to it, enter. Raise it to the power 365, enter. And I get 1.0832777572. I subtract 1 from both sides. Minus 1 gives me 0.0832777572. Written as a percentage, that's going to be 8. I'm going to go now to 1 decimal place. I better go a few more. 8.3278%. That's my annual yield. That's my annual yield for First Federal Savings and Loan, 8% compounded daily. Now let's take Iowa State Bank and let's find the annual yield for 8.2% compounded monthly. Same formula, 1 plus I to the nth is equal to 1 plus RT. I'm going to have my I, which is 0.082, that's 8.2%. What do I divide by? Compounded monthly, I divide by 12. What is N? N is compounded monthly 12 for how many years again? It's 1 year. 12 times 1 year is 12. This would be 1 plus R, which I need to find for 1 year. So this gives me 1 plus R, again, like I did over here. I got to get this on my calculator. Again, that's going to be 0.082 divided by 12, enter, plus 1, enter, raised to the power 12, enter, and I end up with 1.085153122. Subtract 1 from both sides gives me 0.085153122. Write it as a percentage. It's going to be 8.515%. How did that compare to the other one? This was 8.3%. This is 8.5%. This one gives me the better annual yield. Okay? That's an example of comparing the two. All right? Our assignment, again, we're assigning 5.2. We're assigning it today, April 14. It's going to be due April 21. All right? Have a good rest of your day.